In this video, we'll talk about more operators you can use, conditionals, and recursion. We've talked about the basic operators in the previous videos, operators like plus, minus, multiply, and division. A very commonly used operator is modulus, or called modulo. What's modulus? Modulus works on integers and finds the remainder when dividing two numbers. The modulus operator is the percent sign. For example, let's say that we do remainder equals 7 modulus 3 and we print the remainder. Think of dividing 7 by 3, but what gets returned is the remainder, which is 1. Why would you need to know about the modulus operator? The modulus operator is great for checking divisibility. We can check if a number is cleanly divided by another number. For instance, 7 modulus 3, you get the remainder. It's not a clean division. But let's say that you were checking for divisibility. Let's say we were checking if a number was an even number. Remainder equals 6 modulus 2, and we get the remainder. If the remainder is 0, we know that there's clean division. And since divisibility by 2 checks for whether a number is even, we know that 6 is an even number. Let's move on to booleans. What are boolean expressions? Booleans are the type of term used for true or false values. It's our way of telling whether a statement is true or false. For example, we can compare two values, 5 equal 5. This double equal symbol is meant to be used for equality. Two equal operators means that we want to see if the statement is true or false. 5 is equal to 5, so what gets returned is true. In the previous video, we used 1 equal, but that was for assignment. When you use 2 equals, it checks for true or false, checks for equality. Now, if we put an exclamation point before a single equal, it means not equal. That exclamation point means not, and you can use it for not equal. 5 not equal to 5 would be false. There is support for greater than, less than, greater than or equal, and less than or equal. And we call all of these operators comparison operators because we're comparing two values. 6 is greater than 5, that's true. 6 is less than 5, that would be false. 6 is greater than or equal to 6, which would be true. 4 is less than or equal to 4, which would be true. When you use the less than or equal or greater than or equal, the equal symbol goes after the greater than or less than sign. Like how it sounds in English, greater than or equal or less than or equal. Greater than symbol and then the equal sign, less than symbol and then the equal sign. The Boolean values, true or false, when would you even use them? When would you use comparison operators? You use them in conditionals. Conditionals derive from the word condition, of course. Only do something based on a requirement, based on condition. Conditionals trigger a certain behavior based on a requirement of the Boolean value, true or false. Now, these conditionals, the most common one is the if statement. It looks like English. If, parentheses, the condition, colon, print do something. If is the if statement, and then in parentheses you have the condition. If this is true, then do something. If it's false, then do not do the something. For instance, I'm going to write if true, and then you put the tab because they work like functions, and then do something, it's printed out. Because if checks if there is a true statement or not. Now, since we deliberately use true, then the conditional is triggered. The if statement underneath the statement is triggered. But if there is a false Boolean value, then nothing gets printed out because it's based on whether or not that condition is true. Do the thing, do the something. Let's combine it with some comparison operators. X equals 5. And let's say that we're checking if x was indeed equal to 5 with the double equals. Remember, double equals means equality. We're checking if x is equal to 5, and then we'll do the something. Just as we wrote it down, 5 equals 5, and then what was returned is a true statement. So x equal 5 is true. And when we run the program, we do the something. Because the if statement only gets triggered if that condition is true. If the condition is not true, nothing happens. It skips that if statement. Now, we can combine different things underneath the statement. You can have more than one statement run. And in this case, we're going to add 1 to x. And then since the if statement is true, x is equal to 5, then it adds 1 to x. And then we print out x and it becomes 6. You can put multiple if statements underneath. For instance, you can have a line of statements and then you can have different if statements running different conditions. For instance, up here, I'll have x equals 5, but then below it, I'll have something like x is less than 7, and then I'll do something else. Now, both of these if statements are true, and these if statements are completely separate from each other. So they'll both do the something. And in this case, they both add 1 to 5. So 5 plus 1, first if statement, becomes a 6. Second if statement, 6 plus 1, x is 7. You can notice that the format of the if statements always follows if parentheses condition parentheses colon and then a tab to the right and then statement. It's just like functions. The key word here is if, then parentheses, you just have the condition, then the colon, and then tab one thing to the right, and then all your statements. The next thing we'll talk about are logical operators. What are logical operators? Logical operators is the fancy term for operators like and, or, and not for using multiple conditions or changing the condition's meaning. You can put and, or, and not in Python, and they have the same meaning as they do in English. For example, think of a range of numbers. How do I check if a number is greater than 0 but less than 10? Two conditions. X is greater than 0, then we put and then after the and, we put the second condition, x is less than 10. So we can check x is greater than 0 and x is less than 10 in between 0 and 10. Is 5 in between 0 and 10? Well, hey, that is a true statement. X is in between 0 and 10. So this if statement will be triggered and we'll see to do something and x is in between 0 and 10. If I use and, I can check for multiple conditions simultaneously. Both of these conditions must be true for the complete condition to be true. If x was equal to 11, then the condition is false since and, this keyword and, this logical operator requires both conditions to be true. You can see nothing is printed out. X is equal to 11. It's greater than 10, so it fails the second condition. Now let's say that instead of x to be between 0 and 10, we wanted x to be outside of 0 and 10. So we can change this condition a little bit. We can do this two ways. First, we can use the not operator. The not operator is exactly what it means in English. It says that not this condition. So I don't want x to be greater than 0 and x to be less than 10. Do the opposite. Not just means the opposite. So I am checking x is equal to -5. Make sure that it is not greater than 0 and not less than 10. Is x not in between 0 and 10? Well, yeah, -5 is not in between 0 and 10. So the condition runs because of the not. Not means the opposite of what is immediately after it. And in those parentheses, I just check for the opposite. And that condition becomes a true meaning because -5 is not in between 0 and 10. By adding a simple not, we can read the condition as it would read in English. Now let's check the second way that we could do this. We can use x is less than 0 or x is greater than 10. Is it outside of the range of 0 to 10? We can use the or to check whether or not it fulfills both of these conditions. At least one of these conditions must be true. And the first condition, x is less than 0, is true. But then the second condition, x is greater than 10, is false. But or means that any of these conditions can be true, and then the whole condition is true. Because as long as x is less than 0, one part of the condition is true, which means the whole condition is true. We've only talked about if statements so far, but there are more conditionals. We've only talked if something is true, then do something. But what if you wanted to check if something is false? Well, there's the else statement. If you put an else colon underneath your if statement, then you can do something else if the if statement's conditional is false. For instance, if true, then colon, do something, else, if the condition is not true, then do something else. This else statement is very useful if you want to trigger two different behaviors according to your condition. In this case, I just put true and it does something. But the else statement does not get triggered because the else statement is only triggered if the if statement's condition is false. But in this case, I deliberately put true and then the else statement was not triggered. Let's do a real example. Let's say if we were checking if a number x was even or odd. And we can do this with the module. We explained what module did in the beginning of the video. It checks for divisibility. So if we check x is divisible by 2, then we print, hey, this number is an even number. But if it's not divisible by 2, then we know that the number is odd. That's the rule of even and odd numbers. Even, divisible by 2. Odd, not divisible by 2. So in this case, we have 1. And 1 modulo 2 is not equal to 0. There is a remainder. 1 is not cleanly divisible by 2. So the else statement gets triggered because the condition is false. And we say x is odd. This is how the else statement works. If the condition is false, then do the else statement. Let's move on to chained conditionals, which is a fancy term for putting multiple conditions in between the if and else statements. For instance, multiple if statements. Earlier in the video, we talked about the and operator to squeeze multiple conditions into a single line, into a single if statement. But sometimes you want multiple conditions that are not relevant, that are completely separate, and you just want these multiple if statements one line by one line. Think of a multiple choice exam. Who wants to be a millionaire? You have choices A, B, C, and D, and an and operator won't be enough to squeeze everything to one condition because all of these options are separate. A is separate from B, C is separate from B, C is separate from D. Luckily, there's the elif statement, ELIF, else if. Elif allows you to put multiple if statements line by line, and you put them underneath your if statement so you can trigger different conditions according to separate if statements. And here we use elif for B and C, and then we use else because there are only 4 options for our case. It's a multiple choice problem, but there are only 4 options, so we know that the last option has to be D if each of these conditions are false. So how this works is that line by line, these conditions are checked. If choice is equal to A, do A. If choice is triggered with B, then do B. And if choice is equal to C, then do C. In this case, since we did choice is equal to C, only print choice C is triggered because only that conditional is true. Else if statements are useful for these moments when you have multiple choices, and each of these choices are very separate. You can put any number of elif statements underneath your if statement. But what happens if 2 if statements are true? In this example, we'll do x equals 5. And then let's say that we check if x is greater than 0, elif x is greater than 3. Well, 5 is greater than 0 and 5 is greater than 3. 2 if statements are true. When you use elif with an if statement, only the first true conditional is triggered. Since 5 is greater than 0, only that print statement that says x is greater than 0 is triggered. If you wanted 2 if statements to be checked and triggered if they were both true, then you would put separate if statements. But when you use elif, only the first if statement that is true is triggered. We can put if statements underneath if statements. We call putting conditionals like if statements underneath more if statements nested conditionals. Nested conditionals is a fancy term for putting conditionals underneath more conditionals. For example, let's do this. X is equal to 10. And let's say that we're checking if x was positive, and then after x was positive, we wanted to check if x was even or odd. Well, we did x is greater than 0. Okay. And then in that if statement, we do x modulus 2 is equal to 0 to check if it's an even number, or x is odd if x modulus 2 is not equal to 0. And if we print this out, what happens is the first if statement, x is greater than 0, gets triggered. So then 10 is positive, and then after we know that 10 is positive, then we do the other conditionals. X modulo 2 is equal to 0, so x is even. Notice how we do the tabs in this. Whenever you have an if conditional, you have to do one tab right. So when we do the second if conditional, there are in total 2 tabs because of the one tab right for the first conditional and then the second tab right for the second conditional. Now, nested conditionals can also be translated to AND operator most of the time, because here you can see that in the nested conditional, we're checking for 2 conditions that are true. Well, we can do that with the AND operator like we learned before. And we can just check if x is greater than 0 and x modulo 2 is equal to 0, because x is positive and even, and it gets printed out. The main lesson that I want you to get out of conditionals is that they allow you to control exactly what your program will do based on your set of requirements. When you have a set of requirements and you need your program to do a very specific thing based on those requirements, use conditionals.